Welcome to the next video in the Level 3 Electrical Design series from the Focus Training Group. Today we're going to have a look at the values of IT and IZ. First up we have IT. According to the definition in BS 7671, IT is the value of current tabulated in Appendix 4 of BS 7671 for the type of cable, ambient temperature and installation method concerned. This refers to the current values given in BS 7671, Appendix 4, Tables 4D1A to 4J4A, normally where we select the size of our circuit conductors. As we can see in the snippet of one of the tables, 4J4A on the right hand side of our slide, we can see this is a slide for multi-core armoured 90-degree thermosetting insulated cables. So the table here is for the type of cable mentioned. The top right of our table we can see we have three values. This is the air ambient temperature, the ground ambient temperature and the conductor operating temperature. So this means the figures in this table are based on those predetermined values. Then we can see on the table we have our conductor sizes down the left hand side, and then we have different current ratings for different reference methods. So we have reference method C, where it would be clip direct. Then we have reference method E, where it could be on for example, a cable tray. And then reference method D, where it is buried in the ground. So we can see that there are different values of IT dependent on the reference method. For example, for the first column, where we can see for reference method C, one 2-core cable, single phase AC or DC, for a 16mm would be 82 amps. But in the same first column of reference method D, where it's direct in the ground, same type of cable, we can see that it's only got an IT of 71 amps. This is because being buried direct in the ground would affect the cable's ability to dissipate heat, hence it would have a different value of IT. So it's key to remember that the IT values take into account conductor type, ambient temperatures and reference methods, but don't include the other rating factors. How about IZ? Well, again, according to BS 7671, IZ is the current carrying capacity of a cable for continuous service under the particular installation conditions concerned. This value not only takes into account the value of IT, but also the rating factors that the particular installation is subjected to. The IET Electrical Installation Design Guide 4th edition gives us the calculation to be performed to calculate IZ. Now we can see top right that IZ is equal to IT, which is our tabulated values we looked at the last slide, times by any of our relevant rating factors. And as we can see, we have rating factors such as ambient temperature, buried in the ground, grouping, thermal insulation. When using this IZ method to determine the size of our circuit conductor, BS 7671 tells us this will involve a certain amount of trial and error, and therefore suggests a different method where it's not necessary to know the value of IZ. We will look at these two methods shortly. From reviewing the information of the IET Electrical Installation Design Guide and BS 7671 Regulation 433.1.1, we will become familiar with this formula. IB, our design current of our circuit, should be less than or equal to the IN protective device rating, which in turn should be less than or equal to the IZ, or the current carrying capacity of our cable for continuous service under the particular installation conditions. What this formula effectively tells us is we need a protective device that will not operate when our equipment is performing its normal function, and a circuit conductor that will not rise to a dangerous temperature before a protective device operates in its prescribed time. Using the information we can gather from BS 7671 Appendix 4, we can actually substitute IZ for IT. Now our formula reads IB, our design current, should be less than or equal to IN, our protective device rating, which in turn should be less than or equal to IT, our tabulated current carrying capacity of our cable. We can now look at an example using both methods, starting with calculating IZ to choose the size of our conductor. So our scenario is a circuit wired in 70-degree thermoplastic flat sheath multi-core cable. clip direct to a masonry wall. The circuit is supplying a BS1363 socket and is protected by a BS EN60898 20A MCB. The ambient temperature is 35 degrees Celsius, and our cable is to be totally surrounded by thermal insulation for 100mm. Just a recap on the criteria we need to meet, and that is IB, our design current, should be less than or equal to IN, our protective device rating, which should be less than or equal to IZ, the current carrying capacity of our cable given the specific installation conditions. If we use the relevant tables of BS7671, we'll find that our rating factors for our given scenario are CA, or ambient temperature, which is 0.94, and CI, which is our thermal insulation rating factor, which is 0.78. We then look at our formula for calculating IZ, and it is IT times our rating factors. So as stated in Appendix 4 of BS7671, selecting a circuit conductor size using this method involves some trial and error. To demonstrate this, we will use the table shown in Appendix 4, shown on the slide here of Table 4D5, which covers circuit conductor sizes for 70-degree thermoplastic insulated and flat sheet cable. Our scenario says our cable is to be clipped direct to a masonry wall, so we will be using the final column on the right hand side for reference method C. So remembering our criteria that IZ needs to be greater than or equal to IN, we could first choose 1.5mm, which has an IT value of 20 amps. If we then put that into our IZ formula, we can see 20, which is our IT, times our rating factors of 0.94 and 0.78, would give us a value of 14.66 amps. We can see that this is well below the value of the protective device rating, so it does not meet the criteria. We could then go down to choose 2.5mm, which has an IT of 27 amps. If we put that into our formula and times it by our rating factors, we will come out with 19.79 amps as a value of IZ, still below the value of IN. So now we go down to choose 4mm, which has an IT value of 37 amps. We times that by our rating factors of 0.94 and 0.78, and we come out with 27.13 amps. And we can see that this is well above the rating of our protected device. Therefore, we have eventually worked out that we could select 4mm. So now we're going to use the same scenario, but using the IT method. We can see now that our criteria has slightly changed in that we were looking for an IT value which is greater than or equal to our protective device rating, IN. Our rating factor values are still the same for CA and CI. And now we look at our new formula, which is IT, our tabulated current carrying capacity, has to be greater than or equal to IN, our protected device rating, divided by our rating factors, times together. If we put in our figures, we have 20 amps, which is the rating of our protected device, divided by 0.94 times 0.78. We can see this comes out at 27.27 amps. Therefore, we need to choose a conductor size from the relevant part of the table that will quite happily take 27.27 amps. If we again look in the final column, we can see that 27.27 amps would be just above what would be tolerable for a 2.5mm. Therefore, we will choose 4mm. We can see now that, as described in Appendix 4 of BS 7671, using this method may be slightly preferable than using the IZ method. And it is key to remember that using this method is not necessary to really know the value of IZ. We hope you have enjoyed this video. Join us next time where we'll be looking at some more examples of selecting circuit conductor size using this method.